Hello my dear students, I welcome you to Neet World. So today in this session we will be discussing the acid base theories. So in the last class I have explained diboron concept, right? So in this session I will be explaining acid base theories. So I will be selecting very few important topics that must be focused for upcoming EAPCET and NEET exam point of view. So do not skip this video. So watch all the videos which are added into the Golden Minutes series playlist, where I will be focusing only some selective topics that must be covered for upcoming exam. So let us start our discussion on this acid base theories. So first the concept here we have Arrhenius concept. So we have three acid base theories. The first one is Arrhenius acid base theory, and second one is Brønsted-Lowry acid base theory, and third one is Lewis acid base theory, right? So out of that the first one is Arrhenius acid base theory. See, this theory defines acids, bases from the perspective of water as a solvent. For example, any substance. So let us take any substance. If we place that substance in the water, so what he says here is, so any substance if we place in water in the aqueous medium, okay, let us say HCl is a substance. So if we are placing in the water, so if it is increasing the concentration of H plus ion of this water, so what happens here, it will becomes H3O plus and A minus. So if it is increasing the concentration of H plus ion, if concentration of H plus ion is, if the concentration of H plus ion is increased when a substance is kept in this water, so that substance is considered as acid. Okay, now if any substance, let us say, I am generalizing BOH is a substance. Now it is placed in the water, so in the aqueous medium. So if it is increasing the concentration of OH minus ion, if it is increasing the concentration of OH minus ion, so then we can say that particular substances, then this particular substance is called as base. I hope it is clear. If it is increasing the concentration of H plus ion, I am saying this as acid. If it is increasing the concentration of OH minus ion, I am saying it as base. So give me some examples for acid. Let us say I have HCl. So this is a, like HCl is an acid now. So whenever we are placing this in the water, so what happens, it increases the concentration of H plus ions by releasing H plus ions from here. So it will become H3O plus Cl minus ion. So see, H2O become H3O plus. It means I can say H plus ion concentration is increased. Okay, similar to these. Now HCl is what? Now it is considered as acid. Similar to these, we can also give examples for acids as H2SO4, also H2SO4 sulfuric acid we are saying now, and nitric acid HNO3, and acetic acid. So all these things are what? Examples for acids. So what is this? All these are examples for acids. Okay, now the next here, base. So what exactly base is? Okay, so here look into this. The base is which increases the concentration of OH minus ions. So give some examples. See, any species like this NaOH. See, when we keep this NaOH in the water, aqueous medium, it releases OH minus ion. Therefore, concentration of OH minus ion is increased. So I can say NaOH is an example for base, and CaOH twice is also an example for base, something like this. Okay. Now NH4OH will also release OH minus ion. So this is also a base. So this is what the examples. Okay. So this is about Arrhenius acid base theory, and the next thing is Brønsted-Lowry acid base theory. So what he says is, okay, the species which donates proton. So what I am saying, proton donor, H plus donor. So species which donates proton donor. So proton donor is acid. Proton donor is acid, and proton acceptor, and proton acceptor is base. That's it. For example, I am saying here, so let us say HCl is there. Okay, so I am placing this in the water. So what happens here, look at here. So this proton is accepted by this water molecule, right? So that's why it is becoming H3O plus, and the remaining part is Cl minus we are writing. So this is donating the proton. So proton donor is what? Acid. Now acid, HCl is acid. Now the proton donor is this one, and proton is accepted by water molecule. So therefore this is called as base according to Brønsted-Lowry's acid base theory. Okay, now here one more thing we need to know. The donor, see, it is donating the proton, so we are calling it as acid, right? Okay, so after donating the proton, the remaining part, see the remaining anionic part is there now, H plus ion is donated, remaining is Cl minus. So that is called as, conjugate base. The acid, the anionic part, the remaining anionic part of acid is called as conjugate, base. So this is also important point here, conjugate base. There are few questions asked on this concept itself, I will show you. Okay, acid, the negative part of the acid is called conjugate base. See, the base after accepting the proton, it is forming a cation like this. See, H2O becoming H3O plus now. So this positive part is called, this resulting part is called conjugate acid. So this concept is called as conjugate acid base pairs. So conjugate acid. So how can we identify a conjugate acid base pair? See, acid, the negative part of the acid will be called as conjugate base. Okay, see, after accepting the proton, the base will form, resulting to form a conjugate acid. Okay, one more thing you can remember here, a acid and its conjugate base differ by a proton. See, HCl is an acid, so its conjugate base is Cl minus. So how do this pair is differed? Cl minus and HCl. So these two species are differed by one proton. So conjugate acid base pairs are differed by one proton. So look at here also, here we have see here we have H2O and here we have H3O plus, right? So now if this is a base, the cationic form will be called as conjugate acid. Now this base and conjugate acid, so base I am writing it as B and conjugate acid as Ca. So how do these two species are differ? So they just differ by one H plus ion. The difference is only one H plus ion. So always remember, the conjugate base will be having one proton more than the respective conjugate acid will be having one proton greater than their respective base. Now here conjugate base will be having one proton less than their respective acid. So this is what you need to remember. Okay, I hope it is clear. I will show you a few questions on this. Look at this. The conjugate base of H3O plus ion is. So what is the conjugate base of H3O plus ion? They are asking. See, they have mentioned it as, let me take a color. See, H3O plus is given. What is a conjugate base? So what is a conjugate base? See, if this is an acid, so base should always contain one proton less than the acid, right? So if this is the acid, so respective base will be this one. So it means after releasing H plus ion, from this one H plus ion is released. The remaining part will be called as conjugate base. If this is acid, this will be its conjugate base. So what he is asking, what is the conjugate base of H3O plus ion is? So what is the conjugate base? H2O, that's it. Okay, this is very easy and simple questions which is based on theories. Okay, now look at here, if I am taking water itself, so I hope it is clear for this particular question. The conjugate base of H3O plus ion will be H2O. Okay, this is about the question, we can easily take. Now I will be giving you some more clarity on this concept. Just look here. See, I have water molecule. Now I am asking you to tell me that what is the conjugate base of this. What is the conjugate base of this? So whenever we are taking a species and if we are asking for its conjugate base, just reduce by one hydrogen. So just remove one hydrogen. What is the negative part of it? So OH minus will be there now. OH minus and H plus. So if it is releasing H plus, the remaining part is OH minus. So this is called its conjugate base. I hope it is clear. If this is acid, its conjugate base is this one. I hope it is clear how to identify acid and its conjugate base. Okay. Now if H2O is a base, if I am asking you to find conjugate acid of this molecule, so just conjugate acid of this molecule means always remember acid will be having one proton greater than the base. So what is its conjugate acid? It will become H3O plus. That's it. One proton is greater than this base. Therefore this is what? Conjugate acid. Okay. So I hope it is clear. If this is the base, if this is a base, this will be its conjugate acid. If this is a acid, this will be its conjugate base. I hope the difference you got. Now tell me, if HCl is acid, what is its conjugate base? Conjugate base means just release this H plus ion and the remaining negative part will be there now. So this will be called as, if it is acid, the negative part of this acid is what? Conjugate base. That's it. Okay. Now look into one more question here. What is the conjugate base of chloric acid? Yes, this is also important question. So what is the, first of all we need to know what exactly chloric acid is first. Then only we can answer this kind of question. See, from this I can write the respective acid as HClO3. Okay, from this I can write HClO2. Okay, from this I can write HOCl. From this I can write HClO4. So these are the respective acid. So this is called as perchloric acid. Perchloric acid. Okay, this is strong acid. Okay, this is called as hypochlorous acid. Chlorous acid. And this is chlorous acid. Chlorous acid. And this is chloric acid. This is chloric acid. Now if this is the, see, so they are asking conjugate base of chloric acid. So the name of this molecule is what? Chloric acid. Now tell me what is its conjugate base. Just take the negative part of this conjugate, I mean this acid, by releasing the H plus ion. See, if it is releasing H plus ion, the remaining negative part will be ClO3 minus. That's it. This will be the conjugate base of this acid. I hope it is clear. Okay. Now one more concept I want to explain you. I hope this concept is clear. So option D is correct for this particular question. Okay. See, this is asked in the last year only, 2024. Okay. Now I just want to add few more concepts here. See, if an acid is there, after releasing H plus, okay, what will be getting? Conjugate base will be obtained, right? Okay. So now if this acid is strong acid, if the acid is strong acid, okay, if the acid is strong acid, its conjugate base will be weak. Weak base. The conjugate base will be very weak. Okay. For a strong acid, the conjugate base will be weak. So I am making a statement here. It means it is reverse. Like the conjugate base of a strong acid is weak. If it is conjugate base of a strong acid, if acid is stronger, its conjugate base will be weak. It means, let me explain this here. See, these are the conjugate bases. For example, I told you HClO4 is a perchloric acid and HClO3 is a chloric acid and HClO2 is a chlorous acid, HOCl is a hypochlorous acid. Okay. So these are the acids I given. Okay. So out of this, all of this having chlorine as a central atom, right? Okay. Now in this case, what you need to check is, higher the oxidation state of a central atom, more will be the acidic nature. So here the oxidation state of chlorine here is +7. Like that, here it will be +5. Here it will be +3. Here it will be +1. Like this. So higher the oxidation state, more is the acidic nature. Higher the oxidation state, more is the acidic nature. So it means this is stronger acid, then this, then this. This is the acidic nature, right? So I am saying this is stronger acid. Okay. Now what is its conjugate base we will be having? So after releasing H plus ion, we will be having ClO4 minus, and from here we will be having ClO3 minus, from here ClO2 minus, and from here ClO minus, right? So if this is stronger acid, I am saying stronger acid is this one. So if strong acid is there, then respect to conjugate base will be weak. Okay. If this is stronger acid, the conjugate base will be very weak base. Okay. Strong acid releases weak base. If weak acid is there, then conjugate base will be strong. Here it is weak acid I am saying. So this will be strong base it is. The conjugate base will be strong base. If it is weaker acid, weak acid, the respective conjugate base will be stronger. So it means which is strong base here, so this will be strong base, then this, then this. So this is how you need to decide the orders, whether if they ask acidic nature of acids like this, if they ask basic nature of their conjugate bases, you should write in the opposite manner. So identify the option, they are asking about basic strength. So which will be strong base here? ClO minus. Where is the option here? So ClO minus should be, ClO minus is not there, ClO3, ClO2 is given. So ClO2 up to here they mentioned, it means ClO2 is strong base, the next ClO3, then least is ClO4. So first option is the most suitable answer for this particular question. I hope it is clear, there is no confusion in this, right? Okay. So if you really like the content, please share with your friends. Okay. So Lewis acid base concept here we have. So what exactly Lewis acid base concept here? So give me a minute. So what exactly Lewis acid base concept here? Okay. So here, so he mentioned acids and bases. So in his classification, acid and base, so acid is those substance, proton like those substance, electron pair acceptor is called as acid. The species which accept electron pair is considered to be acid. So electron pair donor, electron pair donor is base. According to electron pair donor is considered as Lewis base according to Lewis acid base concept. Okay. Now, so which species will accept electron pair? So electron pair is accepted by electron deficient species. So all electron deficient species are considered as Lewis acid. For example, here I am writing BCl3, I am writing. See BCl3 I am writing. So here in the central boron atom, see boron, Cl, Cl, Cl. How many electrons are there here? So 1, 2, 3, 4, 5, 6 electrons are only present in this BCl3 molecules in the central boron atom. So it means in order to fulfill its octet, it requires 2 more electrons. It means it requires 8 electrons, but it has only 6 electrons. So 2 more electrons are required now. A pair of electrons are required now. Therefore, this BCl3 is considered to be Lewis acid. Similarly, BF3 we can say, and AlF3 aluminum trifluoride, like this AlCl3, all these things comes under what? Lewis acids. Okay. Sometimes there are some octet rule, like there are some molecules they followed octet rule, but they can act as Lewis acids. See, carbon dioxide having 8 electrons around the carbon atom, here octet is filled, but due to the electronegativity difference, oxygen will drag these pi electrons towards themselves and creates more electron deficiency on this carbon. Therefore, since the electron deficiency is present on the central carbon atom, it will act as Lewis acid. What I am saying? It will act as Lewis acid. So CO2, SO3, like this. Okay. Sometimes there are some compounds which are having like empty d orbital. Okay. So for example, PCl5 is there. So here on phosphorus we have empty p orbital, and also chlorine is what? Electronegative atom now. So that will take the bonded electrons towards itself and creates positive charge on the electron deficiency on the central phosphorus atom. Therefore, this species is also act as Lewis acid. I hope it is clear. Okay. So these are some examples for Lewis acids. Okay. So now any cationic species, for example, Fe plus 2, Fe plus 3, CO plus 2, CO plus 3, all these are also comes under Lewis acids. Okay. The next, Lewis base means electron pair donors. For example, any species with negative charge, like all halide ions like this, or OH minus ions, or NH2 minus, some species with high electron high electron rich. So if they have any electron richness on them, so that will be having tendency to donate this pair of electrons, right? Therefore, those species are considered as Lewis bases. Okay. Now there are some neutral species also. See, water is there, on this oxygen we have non-bonding electrons now, these lone pair electrons now, this can be donated as a donated to the other atoms. So I can say water is a Lewis base. Okay, now alcohols, amines, all these things are comes under Lewis bases. I hope it is clear, no confusions, right? Okay, now observe the following species and identify how many of them are Lewis acids. Again, this is last year's question only. Okay, see here AlCl3, I told you aluminum is 13th group element, so valency electrons are 3 and 3 chlorines are attached, therefore 6 electrons are there around the AlCl3 aluminum, therefore it will be having only 6, 2 more electrons are required, therefore it is electron deficient. I can say this is Lewis acid. So AlCl3 is Lewis acid. Okay, here SnCl4 also it is having here tin Sn is there now, so it is having empty d orbital and the attached chlorine atoms are more electronegative. They will withdraw the electrons towards themselves and creates electron deficiency on central atom. Therefore this will be also act as Lewis acid. And CO2 I already explained, this will be also Lewis acid, and Ag plus is also Lewis acid. See NH3 is having lone pair electrons on it, so it can be donated. So I can say NH3 act as Lewis base but not Lewis acid. So only option 2, 3, 4, 5 will be Lewis acids. See here HSO4 minus it is. So minus means it can act as a Lewis base, but as of now they are asking only about Lewis acids. So 1, 2, 3, 4 is the correct option. So option C is correct. I hope it is clear, there is no confusion. Next, ammonia is Lewis base because it is having what? See ammonia. So ammonia is having NH3 we are writing with lone pair electrons like this. No? So this can be donated. So I can say it is electron pair donor. So electron pair donors are what? Lewis bases. I hope it is clear. If electron pair acceptor, that is Lewis, that should be Lewis acid, but it is donating electron pairs, so Lewis base it is. Okay. Strongest Lewis base among the following is. So I will tell you one example here. Listen this is important question again. Okay, so HF, HCl, and HBr and H I am writing. So these are the like see all of them having like hydrogen atom here. So these can be act as acid. They will show acidic nature. Okay, so out of these, which is stronger acid, they will ask first. So before, in order to solve this question, you should get some idea on this. So out of this, which is stronger acid, we should know. See, hydrogen is common in all of these species, right? But here the size of hydrogen is same in all of these cases, but halogens are different. So here size of fluorine is smaller, then chlorine, then bromine, then iodine, because halogens down the group what happens, their atomic number increases now and the size also increases. So we know iodide ion is like having larger size, then this bromine, then this chlorine, then this fluorine. See, hydrogen, fluorine are almost having similar sizes, I mean not exactly same but almost near sizes, and it will be having orbital overlapping to the greater extent. But here the size, due to the size difference, as we go down the group, overlapping is weaker. It means H and I is having large size difference. Therefore, the bond between H and F is very weaker bond. Therefore, it is easily breaks. Okay, if it is easily breaking, it will be removed, like it will be goes as H plus and iodide ion minus. So it means this molecule is releasing H plus ion easily. So I can say this molecule is stronger acid. Why I am saying it is stronger acid? Due to the weaker bond between H and I, easy to dissociate and liberates H plus ion. So I am saying HI is stronger acid, then HBr, then HCl. Okay, so this is the acidic nature. So if this is the acidic nature, I am saying this is a stronger acid. What is its respect to conjugate base? Then anionic part will be iodide ion, and here it is bromide ion, and here it is Cl minus ion, and here it is F minus ion. Okay, if this is a strong acid, what I told you, the conjugate base of an acid, strong acid will be weaker. If it is strong acid, respect to conjugate base will be weak. Okay, like this. Okay, since I told you this is stronger, it means it is weaker. So this is weak acid, its conjugate base will be strong. Conjugate base will be very strong. Therefore this is strong base, then this, then this. Okay, so this is a order of the conjugate base, strength of the conjugate base. This is a strong conjugate base, so you should choose option B as the answer for this particular question. I hope everything is clear. So there is no confusion. I hope this session will be definitely helpful for you. So if you really like the content, please click on the like button and also share with your friends. And if you are really required any content to be discussed in the class, so just write in the comment box. I will be explaining that in the upcoming session. So thank you for watching.